I appreciate everyone that stopped in this morning to ask questions on this that struggle with it. But and some of you had a few of the right statements there. That was good. So this is a paragraph proof where you're kind of just stating things as you go. You're stating you make your statement, then you state why. Okay, your reasons why. So complete the paragraph proof. We're given this triangle with the right angle of L. Now sometimes in these paragraph proofs or in a proof in general, the picture may give you more than they say is given. So they're saying this is your given statement. You're given a triangle with a right angle L. Now in this case, the picture only gives us that. Okay? Prove that this angle and this angle is complementary. Now some of you will go, well, there's a theorem that says that, so why would I have to prove it? Well, really what you're doing here is you're proving that theorem. Okay? So you can't actually use, like if there's a theorem that states that, you can't use that theorem to prove that theorem. Okay? Hey, could you not do that? Because then you tear the bags. That's bad. I know. All right. We are given angle L as a right angle. So the definition of a right, so by the definition of right angle, measure of angle L equals 90 degrees. Very true. Okay, 90 degrees. How many had that? Good. Okay. That's where it gets a little more difficult now. All right. So by the blank, angle L plus angle M plus measure of angle N have to add up to 180. Now we've talked about it a few times. Yeah?
Angle sum theorem?
Almost. Something angle sum theorem. Missing one word. Who said that?
Triangle?
Yeah, triangle angle sum theorem. So by the triangle angle sum theorem, measure of angle L plus measure of angle M plus measure of angle N equals 180. This M means measure of, meaning you need to know that angle measure. So this all these angles add up to 180. Then 90 plus M plus N, measure of angle N, equals 180. So when you compare this statement and this, what's the only difference? Yeah?
They substituted angle M or angle L for 90.
Good. Angle L became 90. All right? And you used a key word there. Substitution. Okay? By substitution. Now, the only way we were allowed to do that is because prior to this, we actually stated that L was equal to 90. So now everywhere we see an L, we can put a 90 using substitution. So that's what we've done there. Did anyone get substitution there? Good. Good. By the subtraction property of equality. How many know what the subtraction property of equality is? I will tell you, you've used that property a lot. Let's say, for instance, if you had 4x plus 2 equals, 14. You use the subtraction property of equality to solve it. How? Logan?
Because whatever you do on one side, it's from the other side. So like if you take away 2 from one side, you take away 2 from the other side.
Good. So since you're subtracting something from each side, you're making it equal by using subtraction, the subtraction property of equality there. Okay? So, by the subtraction property of equality, what do we know? Well, what can we subtract from this side? It's only one thing we can move. Yeah.
90.
Yeah, we can move 90. We know that if we subtract 90 from this side, we get what? All right, I don't have enough. Okay, if I subtract 90 from this side, what am I left with? Good. Natty.
Angle M plus angle N equals 90.
Good. We're left with measure of angle M plus measure of angle N, and then that equals 90. Subtract 90 from each side. All right. Finally, by the blank, measure of angle M and measure of angle N are complementary. By the what? It would seem like you should be done here, right? Well, whenever you're kind of like, well, haven't we said it here? Usually it means by the definition. So by the definition of complementary angles. Bless you. Yeah. By the definition of complementary angles, measure of angle or angle M plus angle N are 90. Definition of complementary angles says they have to add up to 90. Okay. So all those little properties that we kind of ignored, like subtraction property, you're like, well, I just do that. I don't know what it's called. Well, that's a key thing in proofs. You got to know what they're called. Okay. Questions there? All right. Moving on. I want everyone to take a look at 16. 16 says rewrite this paragraph proof. 4-5 is a 2-column proof. Given angle G is congruent to angle S, and it's marked there. Given angle H is congruent to angle U, and those are marked there. Prove I is congruent to T. Okay? All right, and they go through this. They have a paragraph proof. Your job is to break it up into statements and reasons. All right, so right now, I need you to figure out the first statement, the first reason. Go ahead and tell your neighbor what it is. Okay? What do you got?
Triangle angle sum theorem, is that what this is?
That's actually your reason.
Oh.
So what's the statement that goes with triangle angle sum theorem? Diamond?
Angle G plus angle H plus angle I equals 180.
Good. All right. So, by the triangle angle sum theorem, this equals 180. We're done with that statement. Statement and reason. All right. Tell your neighbor the second statement and reason. You get 30 seconds. Statement. Chase, what do you think?
Is it measurement of angle G plus measurement of angle H plus measurement of angle I equals measurement of angle S plus measurement of angle T plus measurement of angle U? So number 2 states measure of angle G plus measure of angle, bless you, H plus measure of angle I equals measure of angle S plus measure of angle T plus measure of angle U. What did I forget up here? Okay, we forgot one piece right here. Okay, Chase has that. What did we forget in that previous statement? Yeah, go for it, Emma.
Angle S plus angle T plus angle U equals 180.
Good. We forgot this. And that's a key piece. In otherwise, we can't actually say this next thing. Okay? Because now we're saying that this equals this. So this piece equals that piece. How are we doing that? Well, we're doing it by everyone? Substitution. All right. Number 3. Guys, we are down to, well, we're past our time where I want to be with this. So we need to pick up the pace. Number 3, quickly, tell your neighbor. Statement reason.
So the angle G of angle I is equals measure of angle T, so measure of angle I is congruent to measure of T, which is subtraction.
That's close. That's actually our next statement. That's our 4th. So there's one thing hidden in there. Grace?
But angle G is equal to angle S and angle H is equal to angle U.
Okay, good. Angle G is congruent to angle S, and angle H is congruent to angle U. What's the reason there? Yeah?
The reason is that it's the given.
Yeah, that's given. Okay? Now usually, I usually put my given at the very beginning. I just list all the given as my first thing, but they've done it right here. That was a given statement. So that's something we put in there. It's given. Okay, we are given this. Okay? So, as Bethany pointed out, the next statement, though, is that leaves, or subtracting equal quantities from both sides of the equation leaves measure of angle I congruent or equal. They actually write it as. Oh, no, they write it as congruent. All right. Congruent to measure of angle T by subtraction property of equality. There we got it. We are done with our proof. You know how we're done? Well, there's two things. One is that they tell us to prove this, and we've actually, that was our last statement, is that. And I guess if we, let me actually use their, they said angle I is congruent to angle T. That was what they asked us to prove. There we've got it, exactly what they stated. And then the other thing we do is we end our proofs. Now I end my proof like the Greeks back in the day. They ended it with QED, which means it is proven, kind of in their language. I don't know the actual, there's like some cool wording that goes with the QED, but I don't know it. I end mine with this. I let you pick your own ending, and then you get to tell me what it is when we do proofs later. Okay, that's mine. Mine stands for something. I won't tell you right now. You guys can guess at some point. Pretty good. I love it. Okay? All right.